8 foot. So let's take a look. Having 8 foot for dimension. Anybody get anything different? 10. Well, let's take a peek. What we're dealing with here, of course, here's the bottom and here's the top. The total distance has to be the same no matter which side we go up, right? So here we've just got 12 and 18 that add up. That's 30 feet. So we know this has to be 30 feet over here as well, right? We've got 4 and 18, so that means this is 4, 18, so at this point we're at 22 feet high, right? Missed the 2 there? Yeah. Then we got that 2 feet there, so that's 24 feet, 30 minus 24, I'm coming up with 6. Unless I missed something there. Nope. 24, I'm at 6 feet. You see it? You got the 2 feet right here. 4 and 18 is 22. Plus another 2 is 24. So that leaves only 6 feet left out of the 30. Any questions? Okay, well, let's go the other direction. I'm going to get some of this mess out of the way. What'd you get for dimension B? 12. Any other answers? Okay. We're going from here to here, right? We have 14, 24, and 10, which adds up to 48. So here we've got 48, better be across here as well. We've got 20 and 6 makes 36. You subtract that, you are left with 12. So 12 feet is our correct answer there. For our perimeter, I get 156 feet. What'd you guys get? 160. That's that 2 feet coming back at you again. There's a shortcut for doing perimeters. If you look at this, you know, this side and this side have to add up to 30, right? These 4 sides together add up to 30 because they have to be the same. So I just put 30 and 30. But these 3 sides, we already added up to 48. These 3 sides also add up to 48. So instead of adding up 12 different dimensions, I can just add up those 4 to get 156. Oh, so you had 78? Yeah. So a couple people did that on the quiz too with the molding. Got to double, yeah. Now if I were to ask you the area of something like this, that would be a very, very different and much more difficult question. Breaking this up would be kind of tough. Putting it into just simple rectangles. There are no simple rectangles really for this one. What I do is just start splitting it like this. Probably look something like that. So you have a 14 by 18, and what's this going to be? 6 by, this was 6, so 6 by 24. And we'll have plenty of time to look more at areas later on in the semester. So we got out of here with the quiz yesterday. I want to pause this for a second. I'll hand. One thing I want to mention to you is once you get these quizzes back, you don't have to be done. I mean, if you're happy with your grades, you can leave it if you want to. But what I allow you to do is I allow you to go back and redo the questions you got wrong, show your work, and I give you back up to half your points. Let's say you had a 5 out of 9. That would raise you up to a 7 out of 9. If you're not sure how to do one, You can work with a classmate, or you can come talk to me, and I'll sit down and walk you through it step by step. I'll still give you the points. The main reason I do is I want to make sure that you've seen it done correctly at least once, and that you have the right answer down, so when you go look at it later to study, you've got it. Okay? But again, don't let the scores on this first quiz get you down. There's a long ways to go yet, and that's only 9 points. Normally what I do is I make you look at them a little bit, and I won't answer questions on them until you've had a chance to look over them and try them on your own. Okay, well, we looked at all of our basic operations on Monday. So today we're going to take a look at what happens when we have problems that look like this. When we look at a problem like that, there's 3 different operations to do. And depending on how we interpret it, we end up with different answers. I mean, it would make perfect sense, since we read from left to right, that someone could come in and say, I'm just going to do the problem from left to right. 7 plus 3 is 10. 10 times 8 is 80. Minus 5 is 75. Makes perfect sense. Is it right? No, it's not the right answer. Well, there's other ways you could interpret that, but before I start showing you a bunch of wrong ways, let's talk about how do we guarantee in math that 2 people look at a problem like that and they get the same answer? Well, they define something called the order of operations. A lot of people misunderstand the order of operations. They view them as a set of steps, and they're really not a set of steps. What they really are is they're levels of priority. Something that's at a higher level happens before something that's at a lower level. So in this order of operations, the highest level of priority is something called enclosing symbols. In some books, you just hear them say parentheses. Parentheses are one form of enclosing symbol, but there are others that we'll run into. The second level of priority, something called exponents. Exponents include powers and roots. So if there are enclosing symbols, we have to do those before we do exponents because they have a higher priority. Third level priority is multiplication. Now we said that multiplication and division are the same operation, so division happens here as well. So if there's no enclosing symbols that we can do and no exponents we can do, then we can do multiplication or division. The lowest level of priority that doesn't happen until everything else that could possibly be done is done is addition. And of course, we've established that subtraction goes with addition. So looking back at our problem here, do we have any enclosing symbols? No. Do we have any exponents? No. Do we have any multiplication or division? Yes. So that's at our higher level of priority, so we're going to do that first. 3 times 8 is 24. Now I did it up here on top, but I didn't really kind of point it out as I did it. I take 2 numbers and I combine them with whatever operation is meant to combine them. So here the 3 times 8, I combine them to make 24. Everything else stays the same. Everything outside of that bracket. So the plus is still there, the 7 is still there, the minus and the 5 are still there. Are there any other multiplications or division? Technically, I should go to the top of the list, but no enclosing symbols, no exponents, multiplication, division. Addition and subtraction is all that's left. There's one of each. If there's more than one item at the same level of priority, Then we do go just like reading a book, left to right. So starting on the left, it's 7 plus 24 first, which is 31, and then we have minus 5. It's 26. Quite different than the 75 we got that first attempt. So let's look at something a little bit more complex. There. It's kind of long, but it's really not that complicated. First level of priority is enclosing symbols. We have a couple of different enclosing symbols here. But remember what we said. If there's more than one item at the same level of priority, we go left to right. So going left to right, this is the first enclosing symbol, the first parentheses in this case that we run into. We need to find its other end. Where's its other end at? Is this one its other end? Actually, in this case, it is. So we're going to now focus inside that blue box. So inside there now, inside that set of parentheses, the order of operations still applies. Are there any other enclosing symbols? No, not inside the box, right? Any exponents? Yeah, 2 to the power 2, 2 squared. 2 squared means times squared means times itself, so that's 2 times 2, which is going to be 4, right? Now you'll notice here, I took out the 2 to the power of 2, put in a 4, everything else is still there, nothing else has changed. So I'm still inside the parentheses. Any other exponents? No. Multiplication or division? Yeah, one of each. How do we know which one to do first? Left to right. So the division here, 12 divided by 4 comes first. So 12 divided by 4 is 3. So we replace the 12 divided by 4 with 3. Next, what has to happen? 3 times 4 is 12. Now I'm going to pause here for a second. You see, at every step I've been taking out the 2 numbers I'm combining and rewriting the whole rest of the problem. I'm going to stop doing that now just for the sake of time and efficiency. If you want to go through and write out step by step like that in your notes, you can always go back to the recording if you have to. But anyway, we're still now focusing inside the parentheses, inside our enclosing symbols. What has to happen next there? Any other enclosing symbols? Nope. Any exponents? Nope. Any multiplication or division yet? No, it's all addition and subtraction, so we're going to go left to right. 8 minus 3 makes 5. So I'm going to erase the 8 minus 3, and I'm going to put in a 5. Kind of cheating, but saves a lot of time and space. What's the next thing that has to happen then? Careful. The 5 plus 12 is left to right, right? 5 plus 12 is 17. Now all that's left in the parentheses is 17 minus 1. We take those out, we combine them to get 16. Now we've reduced everything inside that parentheses, everything inside that enclosing symbol to a single number. That means we can get rid of the enclosing symbol. Now sometimes there's something we have to do when we get rid of the enclosing symbol. In this case there's not. It's just a parentheses. All we have to do is get rid of it. But we have to make sure it's reduced to a single number inside of it. So the parentheses we can take out, the 16 is still there. What about this 7 that was in front of the parentheses with no symbol there? What do we do there? When it's implied, that's multiplication. Whenever there's a number outside of parentheses with no symbol, you can put in multiplication. Do you have to put multiplication in after the parentheses over here? No, because there's already an operation there. There's plus. And we have the 5 minus 3 over there. Now that we're done with that set of parentheses, we've finished that enclosing symbol, we're back out to the bigger problem again. Any enclosing symbols? Yes, 5 minus 3 is there. The parentheses here. We do what's inside, which is just the 5 minus 3, which gives us 2. Now we're down to a single number in those parentheses, so I can get rid of them. I'm going to just take them out. Any more enclosing symbols? No. Any more exponents? No. Multiplication or division? You got it. 7 times 16, which is what? 112. Correct? And now it's all just addition. 5 plus 112 is 117. Plus 2 is 119. Any questions? How many of you think you could have got that one on your own? Okay, well, let's give it a shot. By the way, I'll point this out before the mistake that most people would make right away on this one. Oh, 5 plus 7 is 12. Why can't we do that? Not in the order of operations, okay. Every number, unless it's the first number or the last number, every number in a sentence like this has 2 operations. An operation happening in front of it and an operation happening behind it. The 7 is being added in front of it, but it's being multiplied behind it. Which one of those happens first, addition or multiplication? Multiplication. So we cannot do this addition until we have done that multiplication. There's a more complex method of describing order of operations that actually does that. You go number by number and look at the operation before it and operation after it. Then you see, okay, well, which one can I do? Okay, I'm going to have you guys try one here. Give that one a shot quick. Okay, so what's the first thing we do here? Enclosing symbols, or parentheses. I'm going to box that in. Inside the blue box. Any other enclosing symbols? No. What's next? Exponents would be next. Do we have any? We got it right there. 4 to the second power. So replace that 4 to the second power with 16. Now what's next? Multiplication and division, and we're going to go left to right. 3 times 5 is 15. What's next? Careful. 16 divided by 16 would be next, which is 1. Then it's 2 times 5. Now you got to remember that multiplication and division happen at exactly the same time. Now what? Left to right, we're going to do addition and subtraction. We only have subtraction. So 15 minus 1, 14, and 14 minus 10, 4. Now what? We get down to a single number, so we can get rid of our parentheses and make sure we put in multiplication there. And then, Perfect. We got to do the 2 times 4, which is 8. 8 minus 8 is? Yeah, that was kind of cruel. I'm sorry. All that work for 0. We're not going to go there. On this one, to figure out how to solve it, the first thing we got to do is figure out what that line across there means. What does it mean? Okay, division is what most people will say. And it does mean division. It's what we call a fraction bar. And one of the things it's telling us to do is division. It's also an enclosing symbol. It separates part of the problem from the rest. Separates the top from the bottom. So it's telling us we have to do everything that's on top. Then we have to do everything that's on bottom. Then we're going to have to divide. So if you were using your calculator for this, you'd want to punch in the top first, get a number, punch in the bottom, get a number, and then divide those two results. And that's exactly how we're going to approach it. We're going to do 2 separate problems. We're going to do the top first. What do I have to do first there? Any more enclosing symbols? No. Exponents? No. Multiplication, division? Yes. Going left to right, we got 5 times 3 is 15. What's next? 15 divided by 5 is 3. Next. 3 times 7 is 21, and that adds up to 36. So the top of this is 36. On bottom, first thing we have to do is exponent. 4 squared is 16. And then 3 times 9 is 27. Then left to right. It's all addition and subtraction, so we're going left to right. 27 minus 16 is 11 plus 1 is 12. So the bottom of this is 12. Now we can go ahead and divide. 36 divided by 12 gives us 3. So that works out to be 3. What do you think? Not terrible? How about something like this? Well, we go through the order of operations. Do you have any enclosing symbols? Well, it's not a division symbol. It's a square root symbol. Yep. It's called a radical is the technical name for it, but we'll just call it square root symbol is good enough for now. It's an operation, but it also can separate part of the problem. So we have to do what's inside of that first. So we're going to do all this first. What do we do in there first? The exponent. 3 squared is 9. What's our next step? Multiplication in there. 7 times 9 is 63. What would be next? Addition. 1 plus 63 is 64. Now, just like with parentheses, We've got it down to a single number inside that enclosing symbol. So now we're ready to get rid of the enclosing symbol. The difference is, since this is a root or square root, when we get rid of the symbol, we actually have to do an operation too. What is the square root of 64? 8. So we take out the square root, but we have to change that to an 8. Also, just like the parentheses, we have this 4 in front with no symbol. What's going to go in there? Multiplication, times. Now what? Well, careful, we got multiplication in there. Multiplication happens for addition. So 4 times 8 is 32. And there's 27 plus 32, which is 59. What do y'all think? More fun than a sharp stick in the eye? You're waiting way too long to answer that question. Okay. There are 2 pieces to your homework for today. In your little book, there's Unit 5. And of course, that's the odds again. Remember to check your answers in the back of the book. Make sure you're doing them right. Then in the big book is page 24. Exercise 1-11. That'll be problems 1 through 33, the odds. Now, just like I said before, if you do the first couple and they seem really, really easy, skip ahead a few. Get to the more difficult ones. But make sure you do enough that you'd be comfortable taking a quiz on this, possibly tomorrow.
What was that big book? I'm sorry.
Big book, page 24. It's exercise 1-11, so it's problems 1 through 33, the odds.